If you remember back to the database video, the way I was managing the records is that there's an events table that contains all of the data that's been scraped from Skiddle and Ticketmaster using the APIs. Obviously we don't want to be playing around and messing with this data directly because this is the one record for each particular gig. So I created the records table, and anytime someone says that they've been to a gig, by clicking on it, it's recorded here. So it takes the details from the gig itself, like the event name and the event image, but it also includes user data and the user ID. So this means that there can be multiple records of the same gig, but they're all different dependent on the user. And I added in this selected column, which is just a true or false value. So if someone changes their mind, it's just that value that can be changed. Now that data's in the tables, I had to start using it in the app itself. So to do this, I changed up the gig context provider to go and fetch data from the database. So if we have a look through here, we can scroll through and see exactly what it's doing. So first of all, we are going and fetching the selected gigs for the current user straight from the database here. And then we are fetching a list of all of the available events. And then we've got the toggle gig selection function, so that allows them to select it and deselect it. Then we are fetching the details for the currently selected event, and then finally inserting those details directly into the database. Then I had to change up the front end to use the data from Supabase rather than dummy data, and this meant going through the components that use the dummy data, so that's the gig item, the gig list, etc., and changing out variables to reference the values that are pulled in from the gig context. So you can see we're importing the custom hook here of use gigs, which is where all of the data from the gig context provider is shared from. So having done all of that, this is how it now works. So yeah, looks like a bit of a confusing mess, but it's actually not too bad. So what we've got up here is the gig context, and like we said, we've got the full list of gigs in here. We've got the user selected gigs and the toggle gig selection. Then we've got the Supabase tables down here, and the toggle gig selection will update the records table, and the events table populates the full gigs list. Then over here we've got those two components, so the gig list, which is the full gigs list, and my gigs, which is the selected gigs, and they're fed by these respectively. And then down here, the gig item, which is rendered in both of these lists, contains the toggle gig selection. So that's where the user will actually flick it on and off. And then that updates here, which updates the records table. Alright, so I thought I'd done it. I thought I cracked it. But what I found out was that it actually just felt bad. In changing from using the dummy data to the live data, I introduced some latency, which caused a delay when you selected and deselected the gig. It just felt slow, nasty, and was a poor user experience. I was going to try and demonstrate it here using the simulator, but this build of the app no longer pulls through data correctly, so you'll just have to take my word for it. My first attempt to solve this was by switching from using the built-in use state for state management to using React Query from Tanstack. React Query itself is a library for managing server state and data fetching, and it's meant to make data fetching, caching, and state management easier. But as usual, nothing's entirely smooth sailing, and I ran into a bit of a pickle. So the tutorial that I'm following creates a custom hook to make an API call and returns results, and uses this hook directly in components that display the data. I tried replicating this by building a selected gigs hook and putting in my gig context, but it all just got a bit messy and it didn't work properly. So eventually I managed to get it working by separating the hooks out into these API folders here to make it more modular as well. So you can see I've got a use events list which goes and collects all of the events, and the selected events one here. So these can now be called into any component instead of from the context provider. But this still didn't work. In fact, it actually felt slower, especially when selecting gigs, although deselection was a little bit faster. But why was this happening? Well, while React Query is great for data synchronization, it still didn't fix the underlying issue of the delay caused by talking to the database for each toggle. So to fix this, I reintroduced local state and adopted a hybrid approach of using the custom hooks to fetch the data, but using useState to manage the updated selection. This meant that the UI is immediately updated for the user before the data is synchronized with the database in the background, otherwise known as optimistic updates. So you assume that the operation will succeed and show the result immediately, and if something goes wrong, you simply roll back. Next, I noticed another problem: too many API calls. So if a user is tapping really quickly on a gig, multiple requests will be sent to the database, which could eventually become really costly, and sometimes they override each other. So the way I tried to get around this was by implementing Debounce from Lodash, and I implemented that against the toggle function itself. So basically what this does is it delays the API call made by the toggle function by 10 milliseconds before completing. So if a user is tapping multiple times in quick succession, only the final selection will be sent to the server. So this was done to save bandwidth, prevent excessive database writes, and would hopefully make the app feel a bit smoother. And then finally, in terms of optimization, I just did some simple stuff on the virtual lists like the gig list here, just things like setting the initial number of items to render to 10 so we're not loading in excessive amounts of data. So I actually took away some good concepts from this stage: optimized UI updates for instant feedback, debounced API calls to avoid excessive requests, virtualized lists for smooth scrolling, and balancing local state with server state to make sure that the user experience is on point. However, even after all of this, guess what? It still ran like hot garbage. So I'm gonna leave the video there for now. In the next one, I'll get around to talking about how I actually fixed all of it. So thanks for watching, and I'll see you then.